Started in a few minutes. Morning, Evan.
Good morning. How you doing?
Good. How are things up in the Bay Area?
Pretty good. It's been raining quite a bit, and I think it's going to for the next couple of days, so
Yep,
starting
we're
to
actually
feel like the seasons are changing.
actually getting some rain in the desert this morning and supposedly much more rain tomorrow and snow
Right.
in Big Bear.
Wow, that's pretty cool.
So we have all weather systems active somewhere. Every anything you want just is within the state of California right now.
Yeah.
Rain, snow, probably it's probably sunny somewhere.
Oh, I'm sure. There's always a lot of variety here.
Let's see. Just another minute or so. I'm just going to get my screen set up here a little different. There we go. So it's kind of a small crew today. All right. Can you see the slideshow?
Yes.
All right.
Looks good.
Yes.
All right. Oh, there's Neil. Morning, Neil.
Morning.
All right. Well, I think we'll get started. We waited a respectful couple of minutes for everybody to join, and we'll get going here. Let's see. What am I sharing exactly? Okay. All right. Should be able to see my slideshow.
Yep.
I will. Okay. So we're going to start by just a quick review of our RAG stuff from the previous 7 weeks. There's some topics I just want to kind of summarize. We didn't cover everything to do with RAG. I think you've got some tools you can explore on your own. I just want to cover a couple of things and recapitulate a few things. We may very well come back to RAG later as things develop. I want to move on to a different topic so that we start to add some tools to our toolbox. But for today, I just want to kind of gloss over a few ideas with respect to RAG, and then we'll move on. Today, we'll start a new topic of agents. So a couple of thoughts on why RAG is so important. And first of all, it solves a huge problem with respect to LLMs, which is eliminating or at least greatly reducing hallucinations. So hopefully you've all played a lot with LLMs and you've seen them make things up. And RAG virtually eliminates that by grounding them in the truth. Second, it's turning out to be a huge industry, a huge tool that businesses are using. One statistic I found while looking and researching this was that LinkedIn did something very similar to the toy application we built to do support tickets. They built a production version of the same exact thing, and they found a 28%, so let's round up, we'll call it a 30% reduction in support time spent per ticket by using a very similar system to answer support tickets within LinkedIn. I mean, you can understand that that's huge. That is just a ridiculously large improvement, and that is something that's the kind of improvement that's rarely achieved in business to get that kind of cost reduction or capacity increase. Some analysis says that RAG by itself is a $40 billion industry within the next 10 years. Now, of course, techniques can change and LLMs could get better and not need RAG, but I think the kinds of results that it's returning mean that it's going to be a growing tool over the next 5 to 10 years that businesses are going to continue to use. We may very well hit a wall in terms of how good LLMs can get. My personal opinion is that the current architecture has some limitations to it. But by adding on RAG, you overcome many of those limitations and you can get incredible results with relatively low effort. So right now, if you look at sort of the balance between fine tuning and retraining versus RAG, 80% of businesses are choosing RAG. It's cheaper, it's faster, it's easier, and it just delivers really good results with much less tweaking, much less retraining, etc. So if we think about it, I like this analogy. RAG is like a library card. So an LLM alone has a cutoff date for its knowledge. They're trained up to a certain date and they don't learn beyond that. That's especially important in business. Let's say we build an expert for Vuori that knows everything about Vuori products. Well, if we use traditional training methods, that has a cutoff date, and new products that come in will not be inside the LLM. But if we look at training a generic LLM that just has good language capabilities, and we add the extra knowledge using RAG, well, then the knowledge never goes out of date. We separate the duties. We use LLM for its language manipulation capabilities rather than its knowledge, and we use RAG for the knowledge. And we can constantly be updating the RAG database. It's trivial, it's easy, it's well understood, it's very similar to updating any database. We know how to do that. And so it separates the duties into the component parts that are really well understood. So as we showed, we kind of built out a workflow, and this will actually transition into our next topic of agents, but let's call it a workflow. The workflow is a user types in a query, we embed that query, we search our vector database with the embedded query, we retrieve chunks of the data that we previously stored, we combine those in the form of context. We build out a prompt using the query, using the context, and we send that off to the LLM to get an answer. And all of this can happen very fast because each component has been optimized to do its job very quickly and very thoroughly. So we have a very nice workflow. It's very deterministic in a sense. We have only really one part that's non-deterministic, which is the LLM response. So we have a lot of control over what happens, and we can programmatically check our work. We can use other LLMs in the process to judge the quality. Remember, we added that at the end of our workflow chain. We added the ability to judge the quality of our answer. We also added other LLMs to add guardrails to both the input and the output. So there's lots we can do, but we have control over the path of execution. So again, review, we used an embedding model. Again, it's not quite an LLM, but we used an embedding model. There are lots of other embedding models. We used a very simple one that had 384 vectors. The standard is much bigger. OpenAI's Ada 002, which is actually fairly old, but it's well understood. It has 1,536 dimensions, so roughly 5 times bigger than what we were using. There's other open source options. There's hundreds of them. You can train your own. There's a number of classes available on the internet to teach you how to train an embedding model from scratch. It's well understood. In fact, the embedding models were invented before the LLMs because Google, in their a lot of their early translation efforts, would use embedding models before LLMs could do the translation, and they were doing translation more mechanically. They still used embedding models. So there's quite a few of those lurking around from those days. And you can go out and find them, you can understand them, you can program them, you can experiment with them. Very cool stuff. Now, one thing we talked about in the first class or two, but we didn't implement in our agent, is the idea of chunking strategy. So I just want to, as we kind of wrap up RAG, I want to talk about this because it's a very important part of most RAG systems. When we ingest documents, the documents in our app were very small. They were answers to questions. So they typically were relatively small number of words or tokens. The questions were small, the answers were small. But when we look at real world RAG systems, often they're dealing with quite large documents, computer manuals, encyclopedias, whole web pages. And so they're too big. This was especially a problem in the early days of LLMs, where our context windows might have only been a few thousand tokens. Now we have much larger context windows, but we also know that if we push that too hard, we get poorer results. There's a strong drop off as we add more and more stuff to the context window. So we still want to be very conscious of not overloading the context window. And of course, if you look at a chatbot and you have multiple turns, it keeps all of that in memory in the context window. So as you ask more questions, as you ask follow-up questions, the context window gets clogged up. So we don't want to just jam the entire Encyclopedia Britannica into the context window and hope for the best. We want to be very focused on what we add to the context window. So one way we do that is when we're ingesting documents, we chunk them into manageable byte sizes. Very typically, we might choose 512 tokens as a good chunk size. And so there's different strategies, and we can use a fixed size. We just say we're going to take 512 tokens at a time, and we're going to use our embedding model to determine the semantic meaning of that chunk, and then we're going to store the chunk and the vector in the database. That's pretty much what we did in our app. The first sort of improvement over that is we can do sentence-based. We don't just chop off the chunk at 512. We look for the nearest sentence ending. So we don't stop the chunk in the middle of a sentence, because that makes it hard to understand the meaning of that final sentence. So we use sentence endings. We use a smart chunker that looks for the ends of sentences. Then there's another way to do it, which is more semantic. So we use a smarter chunking strategy. We try to break things into semantic chunks. So one chunk might be just 100 tokens, another chunk might be 1,000. The sizes are quite variable depending on what's going on in the chunk. So that's obviously much more expensive. It takes a lot longer to go through the documents and do this kind of chunking, but it's probably worth it. Finally, another strategy is to do recursive chunking. So here we have kind of a parent-child relationship. And what we might do is we have the document. Let's say we have a book. The book is divided into chapters. The chapters are divided into paragraphs or sections. Sections are divided into paragraphs. We could go through and look at each paragraph and associate that with a section. We can have each level of the hierarchy could be embedded. So we could have a meaning at the paragraph level. A paragraph belongs to a section. The section could be embedded, to have a semantic meaning, then we could look at the chapter, and the chapter could be embedded to have a semantic meaning. So we could go up and down the hierarchy depending on what we're doing, and that is some of the most accurate and interesting stuff. But if we go back to just the fixed size and sentence-based, very simple, very easy to implement, but what we can do to overcome the fact that we might be chopping things off in the middle of a paragraph or even the middle of a sentence, we can actually have an overlap. And if you go back to the very first class, I think, where we looked at chunking a document, we used, I think, 512 characters or 512 tokens, but we had an overlap parameter. So what happens is, if we take just straight 512 chunks, it'll actually take an extra 20% of that will be overlapped with the previous chunk or the next chunk. So we don't just cut things off and have each chunk stand completely alone. Each one is overlapped with the next and following chunk. So we get some carryover. We have some duplication. We have 20% duplication, but this interleaving, this overlapping makes sure that we don't cut off meaning in the middle. So we get a little better results that way. So as this statement says, you can get very bad results by having a bad chunking strategy. So at the minimum, you want to use overlap, but you may want to investigate recursive. And remember, we looked at LangChain, but Llama Index actually does a really good job of this. And we'll talk about that in a minute. There's also the notion of hybrid search. And again, going back to the first class and second class, we talked a little bit about adding metadata to the vector database. So most of the vector databases so we talked about, we store the vector, which is our semantic meaning, and we store the text in the vector database. Almost all of them allow you to also store metadata. So you can store the name of the document it came from. You could store the date and the version of that document. You could store the chapter and section it came from. You could store a star rating that somebody gave it. They're very flexible. So you can store a lot of different keywords. So there's another type of retrieval called keyword search, and there's a different kind of model. One of the most famous is BM25, which will extract keywords from your documents. So you can do both at the same time. You can do vector embedding and create a vector key. You can also do BM25 keyword search and take all the keywords that you find using that model and put those in the vector database as well. And it turns out that it is a really good strategy to use both. So if we go back to our ticket system, we could have keywords extracted from historical tickets, and then we can use those when a user asks a question, we could extract keywords out of their question. And keywords that would be really important would be, what product are they referencing? What problem are they referencing? And we can do a semantic search, which is very helpful, but we could be missing some semantics reasons. Wordings could be different, and maybe our semantic model isn't picking up on those, but the keyword search might be a fallback. So the combination of using both vector search and keyword search together is extremely powerful. And in production systems, that's probably the direction we would go. As I mentioned just a minute ago, there's two really big frameworks in this space. LangChain, which we showed LCEL, and we showed constructing a pipeline. The other one is Llama Index, which is actually my personal favorite. Llama Index happens to be really, really focused on RAG. So it is a good choice, and it has a lot of libraries built specifically for RAG. that hybrid search and hierarchical search are built right into Llama Index. So it has a lot of really great tools for that. And you can use both of them, although I find that to be a little bit confusing. So definitely worth a look. In fact, an exercise you could assign yourself is to go back, take our ticket system, convert it from LangChain to Llama Index. Would be a great exercise, and see what the differences are between the two. Llama Index does not have the LCEL type language. It uses more straightforward Python function library calls, but you can chain those together. It works pretty well. The choice of our vector database is another variable, and we used ChromaDB, but basically what you want to look at is how is this going to scale up? If you are going to launch your idea and you need to handle a lot more users, ChromaDB and FAISS, Facebook search, Facebook has a very free open source vector DB that's similar to ChromaDB. They both start for free and they both do a really nice job, but they don't necessarily scale up to millions of users. So if you've got the next great idea and you're gonna launch the next big billion-dollar company, ChromaDB probably isn't going to take you all the way. But the nice thing is there's very similar things that can scale. So Qdrant and Weaviate, those are two that really cover the next level. They're cheap, $9, $25 a month, and you can go up to thousands to hundreds of thousands of users. And if you need to go up to the huge level, there's Pinecone, which again, they all work basically the same ideas, but Pinecone scales up to multi-user, multi-tenant, multi-region around the world, installed in nodes everywhere. So if you need to go up to, again, millions of users around the world, 24/7 availability, etc., maybe Pinecone is the way to go. There's other options as well. Built into Azure, there's vector DBs. PostgreSQL has vector DB built into it. So you have multiple ways to go. The idea is you want to think ahead how to scale this up. If we're just starting with a toy system and you show it to the CEO and they say, let's launch this across the enterprise, we want to have a way to get there. And one of the big bottlenecks will be the vector database. So ingesting the documents, we didn't really, talk about hugely. We showed PDFs early, we showed our tickets later. That's a huge area where there's a lot of fine tuning that can be done. And it's an area that's fraught with difficulties, to be honest. PDFs are very difficult to ingest, actually. There's lots of good libraries out there now. We use a simple one at the very beginning to ingest some stuff. But if you take just about any PDF from a book to a scientific article, they have structure to them. They're not just straight pure text. They have sections, they have headings, they have footers and headers, and all of that stuff. If you just do a naive ingestion, all those footers and headers and stuff will kind of pollute your data. So you should be handling them. If you actually go in, if you ingest a book and then go in and look at the chunks, you'll see page numbers, you'll see footers, you'll see footnotes mixed in with the text, and that's sort of wrecking your semantic understanding of what's going on. So cleaning up the documents is a huge task if you're going to do this for real. So one possible pipeline, and you can see there's literally many steps to this. You want to split the document into logical sections so that you're not chunking across sections, so that you don't have the end of one section combined with the beginning of the next. You want to remove what we call boilerplate, the headers, the footers, the footnotes, remove all that junk. You want to normalize the text, make sure the fonts are the same. You can extract titles and use that as metadata. Use your section headers as metadata, and that feeds right into the next section. Number 6, add metadata. Then you want a smart chunking strategy. You don't want to cross section boundaries. Then you can do your embeddings and storage. And then you can do a QA step. And then you can find the problems that still remain. And then you can go back to step 1 and start again. So the document embedding strategy, we had a very easy problem. We had these well-defined tickets. They had no headers or footers. We just embedded them. But in the real world, if we want to do a good job of embedding many, many documents, we have to have a nice pipeline for doing that. So for parsing PDFs, some tips. There are a number of parsers. PyMuPDF and PDFplumber are two of the big libraries. A couple things to look out for. What if you're using scanned images inside the PDF? You need to do OCR on them. You can't just chunk the text. What if your PDF has multiple columns? Things get confusing. What if there are tables embedded? You have to do special processing to handle tables. They're very tricky. And so many documents that we would reference in business would have tables of financial data or scientific data or comparisons. Again, we've got headers and footers and page numbers that have to be cleaned up. We have text that goes across pages. We have to reassemble the page breaks. So PDFs are not trivial to parse. That's one reason I didn't do them in the class, is because we could do 10 weeks of class just on how to properly parse PDFs. And so it's a big subject of study. As I mentioned before, we can increase our accuracy using metadata. So we already talked about this, but by some studies, it triples our accuracy for retrieval. So semantic search is great, but metadata search is also a superpower. And if we add them together, we get 3 times the accuracy. So how do we think about success when retrieving documents? Relevance. We want to test relevance. We did that built into our tools. We showed what the documents were. We came up with a relevance score. So we were doing that kind of all the time. So is the right document being retrieved? And we want to find 90% of those. Is the answer grounded in the sources? We want to check our answers against the sources. We built a little tool that did that. We want to use humans to rate the answers. So we wanted, in our QA step, we want to have a human panel or humans give a thumbs up or thumbs down to the quality of the answer. And we want to return our answers quickly. So I think we achieved most of that in our problem, but again, we chose a pretty simple problem. The other thing we want to do in our testing is we want to create a gold standard of real user questions as a test database. So we want to construct testing. We want a database of good questions that exercise our whole workflow and make sure that we're answering difficult edge case, complex questions, and that we're getting sensible answers. So, and we want to look at ground truth answers, and then we want to compare what our system is giving us. So we did a little bit of that. We compared our answers against our original answers and judged the quality. That was, I think, in like week 5. We also want to do some A/B testing. We may want to do our old system, which was humans answering our tickets versus our answers. And then we want to measure both the quality of the answers based on human feedback. So it's maybe early on, we want to take 10% of our tickets and run them through the automated system and give those back to the people asking the questions and ask them to rate the answers. And then we can compare those ratings against the human answers. Then we also want to measure how much labor reduction we're getting. So we want to compare our return on investment versus the quality of the answers. If our tech team is giving answers that result in a 4.5 rating, and our automated system is giving a 4.3, and the ROI is 28%, like LinkedIn had, maybe that's good enough. Maybe we can even get 4.7% by augmenting our answers with other knowledge. So we can continuously measure both our return on investment and our ratings for our answers and kind of judge the quality of the job we're doing and the money we're saving. And then we also want to think about the future. How can we architect the whole system? Assuming it's a giant success, we need to be able to understand how we're going to scale it up. So we need to be thinking ahead on architecture. Then the last topic we covered in class was locking down for security. So we need to understand a couple things. We built a simple guardrail system to prevent injection attacks and misuse, but there's other things to think about. Audit trails, who's using it? What are they using it for? We want to think about access controls. Who's able to access? Who's able to get at the metadata? We want to talk about where the data is going to live. But another big thing is we want to look at PII, that's personally identifying information. And we want to possibly put things in here to scrub all the communications from any personally identifying information. So what do I mean by that? Let's say that a user submits a ticket and they're not very smart and they put their access token. They say, I need your help and here's how to log in as me and here's my access token. We don't want that. We don't want that stored anywhere. So we might scrub the input to make sure that if someone submits an access token or a password, we reject that ticket right away and we don't store it anywhere. We may also want to scrub our output. Maybe somewhere deep in our vector database, we accidentally ingested a token. We accidentally ingested a password. We accidentally ingested somebody's name, address, and social security number somewhere. We want to scrub that, maybe on ingestion or on output. So PII scrubbing is a huge, huge area of research, and there's lots of commercial solutions for that already in existence. We may want to consider building that into our system. So that's what I wanted to talk about. Any questions before we proceed? Any final thoughts?
The last bit there just reminds me, Tom, of a time I was running a booth at a job fair and somebody came up and handed me their resume, and at the top of it was their name, address, date of birth, and social security number in massive letters. And I spent about an hour tracking this person down and asking him to go get all his resumes back.
You mean they didn't actually have a photocopy of their credit card on there as well? So that reminds me of a story. I worked with a guy a long, this is like 30 years ago, who had actually served time in federal prison for running a scam. And he and a group of other guys, this is a long time ago. This is before the internet. What they would do is they would fly into a city and say, we are a big government contractor. We are looking for top quality engineers to join a government project. We're conducting interviews at this hotel, which was not atypical of the time. So they would fly into Atlanta, they'd advertise in the newspaper, we're looking for the best engineers in the country for this project. So people would come, they'd bring their resumes, and these guys would collect all that. Then they'd go and start applying for jobs using those resumes. And of course, because it's a government job, they'd bring in a photocopier. You brought in all your IDs, your driver's license, everything. They'd photocopy everything. They'd make a fake driver's license with their picture on it, but your information. They'd have your social security number, and they'd go apply for jobs as engineers. They knew nothing about engineering, but they could fake their way through an interview. They had a great looking resume. They had a real name, real social security number, security clearances, everything. They'd get a job, and it would usually so you start at a company. What do you do the first 6 weeks? You're in orientation. You're being walked around, being introduced. You got HR meetings. You sign up for the 401k. It's 2 months before anybody even hands you a work assignment. And if you're quick on if you're a con man, you can probably stretch that out to 6 months before anybody actually figures out you know nothing of what you're talking about. So these guys would just go from job to job, and it took years until finally people, the real people, were starting to get letters from the IRS going, you have like 5 jobs worth of income that you never declared. So it took years to catch these guys, and finally they got caught and they went to prison or whatever. But they made millions of dollars on doing this stuff. So just a reminder that there's evil people out there.
I feel like crime was more fun back then, Tom.
It
was more
interesting. Yeah. Well, and it was personal. It wasn't mass produced.
Yeah.
So, a fun diversion. But yeah, I've met some interesting people along the way. Over some time, over some beers, I'll tell you, I spent a couple of years working as an expert witness for the Department of Justice on some illegal banking scams. And it was a fascinating look into the world of scams and frauds and whatever. And it was an enjoyable part of my career. All right. Well, we'll talk about it. Let's go back to real stuff. Workflows versus agents. So we talked about a workflow. So let's start to migrate into agents, which is like the super hot topic of the day. So we talked about our RAG workflow, query, embedding. All of this was handled by our program. We wrote a Python program that walked us through very deterministically every step of the way. So what's the difference between a workflow and an agent? A workflow is just a sequence of tasks orchestrated by our code. And we define it, we write the code, and we have a predictable path of execution. That's not to say every piece of it is predictable. The answer from the LLM is not necessarily predictable, but the path through our code is predictable. With an agent, an LLM decides the sequence of steps. The path is not predefined, or pieces of the path are not predefined. The agent doesn't just answer questions, it actually sits above the whole process in addition and reasons about the sequence. And the actions, not just the answers, but the actions are based on the task and the feedback from the LLM. So we have what we call the autonomy spectrum. In a workflow, it's a fixed, there's no autonomy in a sense. The path is fixed. In an agent, the path is not fixed. So our success will lie in balancing what the user needs versus the risk of letting the LLM do whatever it wants. So again, the distinction is we have a loop or we have a path. Who controls that? In the workflow, the developer writes the code logic, which calls an LLM, which gives a result. In an agent, there's a goal. The LLM decides how best to achieve that goal, and it uses tools and feedback and iterates potentially over that in a loop. So as an example, in a developer controlled workflow, we have input goes into an LLM. The LLM can call tools. The tools give results. They may feed an LLM, and then we get an answer. Very similar. Our ticket workflow, we embedded. We used the embedding. We did translation, but it was all very much in a loop, in a straight path that our code controlled. In an agent, we may just have a chatbot. We give the LLM input. It looks to use tools. It decides which tools in its library that it will use. It takes the output of those tools, feeds that back to the LLM, which thinks about those answers, decides if it needs more tools, thinks again. It could go around and around this loop 20 times or once, and then gives the answer when it decides it has sufficient information. So it's fundamentally a change in who's controlling the process. Here's an example from some work that I'm currently doing. I'm building an agent that interrogates Valo. And I just plugged it into a chatbot, LM Studio. So here's the workflow. And you can see, I just said, what's the average square footage for stores in Northern California? And you can see it thinks, it calls the tool get knowledge. So it has to see what reports are available to it. And you can see it thinking, we have a store details report that includes store details like the address and square footage. So it went out and looked at the available tools. Then it looked at the available reports within one of those tools. And so then it goes and gets the report info for that particular report. So you can see it determined that the store details report has a certain ID. It uses that ID to get the metadata about that report. It then runs that report. It gets the data back, and it figures out from that, it adds up all the square footage for the stores in NorCal, and it returns 3,339 square feet. Brendan, does that sound like about the right amount of square footage for NorCal?
For all of NorCal? That's a good question.
Yeah.
I guess probably, right? 8 stores. Yeah, that sounds about right.
Probably reasonable. So,
Yeah.
So you can see there's no programmatic control here. The LLM decides and thinks through every step of the way. Now, you have to be using an LLM that has tool calling capability and has sort of thought capability. That has to be a thinking model with tools enabled. So there's, when you're looking for an LLM, if you're trying to run something on your laptop, you're going to need an LLM that has these capabilities. So we talk about the autonomy slider. So we have pure workflow. This would be our agent system. And we have pure agent like we just saw. But it doesn't have to be all one or the other. We can kind of, slide between the two. We can use aspects of both to achieve a goal. So some ways to think about this. Use workflows for structured, repeatable tasks where you need predictability. Answering tickets is probably it's a good idea to be predictable. You don't want the LLM taking 20 minutes of thinking to answer a ticket when you've got a nice RAG database that can answer it in 500 milliseconds. The strengths are that it's predictable. Also, the costs are fixed. You know how much it's going to cost to answer each query. It's easy to debug. You can judge the quality of the answer. But it's rigid, and you've got to spend a lot of time engineering the workflow. So it's great for pipelines, for content repurposing, for translating documents, for fixed workflows. So you want to use agents when you have more open-ended things. So a chatbot, if you want to answer generic questions like what's the square footage, and you don't have fixed solutions for that, or there's so many possible questions that could be asked like that, you want a more flexible system. And chatbots, plugins for chatbots are fantastic examples. We don't know what crazy questions the user is going to ask. So we want to build something that's extremely flexible. So it needs to be adaptable. It needs to handle unknown paths. So complex research, if you've used deep research on any of the frontier models, here's an example where if you turn on deep research on any of the models, and you probably need a subscription plan for this, but it can go out and work for an hour. Some of the models will work for 10 hours on a problem. They will do 100 web searches. They will interrogate hundreds of scientific papers. They will bring all that back and synthesize it and then go out and search again based on what they found. So they will iterate repeatedly until they come to what they believe is a good answer. A pipeline really can't do that. But you have to think through. So Cursor is a programming IDE. It's a development environment, and it's one of the most popular to assist in writing code. So one of the things that Cursor does is it'll edit your code. You can say, hey, go change this in my code. They had a very simple system early on that would take roughly 2 seconds to execute a file edit. So they decided to get clever and they built an agent, and the amount of time it took for a simple edit went from 2 seconds to 15 minutes. The users just stopped using it, and they just started going back to find and replace on their own manually because it was better than the agent. So agents don't solve all problems. For simple, straightforward tasks, you're better off using a standard workflow or just programmatic stuff to begin with. So agents don't solve everything. You have to think about whether they're appropriate to the task. A hybrid approach makes sense, just as we saw with RAG. A hybrid approach between semantic search and keyword search is often the best answer. So most real-world systems are probably going to be hybrid. They're probably going to have aspects of both a sort of a rigid workflow, and they're going to have agents that take up part of the work. Oftentimes, we can let users decide. Do you want to use an agent for this task, or do you want to just go, at it more straightforwardly? So a couple of examples: document summarization, probably a workflow. We take a document, we look at the type, we feed it to an LLM that's specialized for that type. The LLM generates a summary, we extract metadata, we save it and display it to the user. It's a workflow. We don't need agents here. We can build a pretty straightforward workflow. Coding agents, on the other hand, we don't exactly know what's going to happen, and this is more of a loop. We have context, we have the code base that already exists, we have documentation, we have notes, we have user queries. So what typically happens, we have the user make a request, add a feature, analyze the code, clean it up. So the LLM first drafts a plan and it uses tools to do that. Maybe it needs documentation, so it uses a tool to go gather documentation. Then it executes the plan, which is a bit more of a loop. Then it generates code. Then it evaluates that code. Then it runs it by the human, perhaps, to say, is this good? Is this what you wanted? So we can sort of do a hybrid approach here with a human in the loop, but large parts of it are agent-based. We have the idea of a vertical hybrid agent, where we have a user request that goes to a router that then feeds possible scenarios. So if we have some kind of a reporting system, we have to decide which type of report they want. Maybe they want a financial summary. We have a specialized LLM or agent that does financial work. We may have one that generates reports from a database. We may have one that analyzes documents. So we essentially use a hybrid agent to make a decision as to which LLM. We look at the answer, we summarize, and we can use some tools then also. So we have kind of a loop here, but parts of it are programmatic and parts of it are open-ended, which use tools. We talked about a deep research. Again, it's a hybrid. We combine tools and agents and programmatic steps all in one thing, and we use an orchestrator agent to pick and choose the steps. So again, combining the two notions into a hybrid is very, very powerful. It's very fuzzy where the line is, and that's where experimentation, you can write your own agents, you can use off-the-shelf agents, you can write your own code, you can use LLMs, you can use RAG. There's lots of different pieces now that we can combine, and we can decide how much of it are we going to control rigidly and how much are we going to let happen. So a little bit of an algorithm. Probably the thing that makes the most sense is start with a simple, fully controllable system. So if we go back to our ticket agent, we have a fully controlled system. It takes an input from the user. It has steps. If it's not in English, it translates to English. It embeds the query. It does a search of the vector database to retrieve relevant context. It combines that context with the query. It submits that to another LLM to answer. It presents the answer to the user. There's no step that's guesswork. Each step happens in sequence. And at the very end, really where we left things is we presented that essentially back to the agent. The agent can decide whether to use that answer or not, or embellish upon it, augment it, etc., and then copy that to an email back to the user. We can then potentially add more information or more agents. What if we could add an agent that went out and looked up more information? So, for example, suppose we had an agent that looked at documentation for every product that we carry. We have the Dell 13-inch XPS laptop. We have all the documentation for that. We could have an agent that would, while we're generating the answer, it could also go look at the documentation and look for relevant pieces of the documentation that might help the agent answer the question. It's not in our RAG database for some reason, but we could have it via an agent. So we could make a hybrid system out of what we built. We can let the user, which in this case is the agent, our tech person, decide which of those pieces they're going to use. So we let them control how much autonomy to give. And then finally, someday, we could make the entire thing autonomous and just have it automatically craft the answer and send that back to the user asking the question. So we could use that as an example of walking through all these steps. So for your project, you want to make a conscious decision about how much autonomy. You want to start simple and add complexity so you understand where all the problems might be. You want to start up by using a human in the loop. We want to use our tech person as a safety net before we just automatically send answers back to the end user. And we want to give them control over that level of autonomy. Eventually, if we are getting 5-star answers every time, we may decide, hey, this is good enough. We can let it run autonomously. So we'll get into this more next time, but I just want to introduce the concept of model context protocol. So this is what's currently being used for creation of agents. So what's the problem that MCP solves, model context protocol? Well, we have a lot of LLMs. We have a lot of different models, and we have a lot of potential agents and a lot of different things we want to connect to. If we want to connect every agent to every source system, we end up with M times N connectors. If we have M models and N agents or sources, we end up with an explosion of connectors. So that's ridiculous. We have to maintain all of that. So what people came up with, and in fact, Anthropic, the people that created Claude, came up with Model Context Protocol, which is a standardized way for models to talk to sources. And so instead of, an explosion of connectors, we have M model connectors to the MCP and N connectors to sources, so we only have M plus N. So it's a huge reduction in the amount of stuff we have to deal with. They call it the USB-C for AI applications. Just like USB-C connectors, we don't have to have a new type of connector for everything. For users, it's consistent and predictable. For developers, we can build one agent and make sure it follows the MCP protocol, and we can just plug those in. For providers, they can build a thing that accepts new providers, new plugins, and it's all very straightforward. So the architecture is pretty simple. We have our AI host, so that could be Claude, it could be Cursor, it could be VS Code, it could be LM Studio, and it allows us to drop in MCP clients. Somewhere there's a server running, could be on your local machine, could be in the cloud. It doesn't matter. The protocol handles both. And so the client that's now inside of your host talks to the server, and then the server stands as an intermediary between the AI and the data source. Very simple, straightforward architecture. What happens is we have sort of categories of capabilities. So within this, we expose capabilities. So we have tools, we have resources, and we have prompts, and then there's another special one called sampling. So a tool is like an executable function that can do something for us. A resource is probably something like documentation or documents. It's kind of, or a database. It's sort of read-only information. A tool will go out and execute something. Its resource will return data from a read-only documentation. A prompt is a template that helps, we can fill in. The LLM can use it as a thing it can fill in and generate answers. Sampling is more complicated. It's sort of a two-way thing. It allows the server to actually use intelligence back in the LLM to execute something and then look at the answers and see where it's getting. We'll get into that in a little bit more detail. So just the way I want to end is just to quickly show you how we can install a quick server, and I'll just share something different here. So let me share a window. So basically, you can go to sorry, I'm just going to pull up, while I'm doing that, I'm also pulling up my LM Studio. You can go to Hugging Face and see they have an MCP server that we can plug in. So we're going to do that right now. I'm going to go over to my LM Studio instance. So running on my Mac Studio is LM Studio. Okay, and this is just the chat window, and over here you'll see a button that says Program and Install. And if you drop down Install, you'll see MCP, and you can edit mcp.json. And here you see it just says MCP servers. It's all blank. So I'm going to take what was in the server definition at Hugging Face and copy it real quick. And paste that in. One sec. Sorry about that. It's not. There we go. So that's how we tell it, how it defines a server, and you notice it's using a remote server. So we can save that. Actually, it's showing that I have an error here. A little bit messy here. Okay, if we save it, yeah, I still have, shoot. I have something, it didn't copy over quite right. Okay, well, I'm going to leave that till next time. We're out of time. I apologize. I had this all set up. It was working fine, and now for some reason, I am not really seeing what's going wrong here. But
Perfect starting point for next time.
Yep. I tried to time it so I was going to go out with a bang. So instead, I went out with an explosion, a bomb. It's really simple, unless you I copied over exactly what Hugging Face had, but there's a little bit of a tweak that needs to be done for LM Studio with the name. Anyway, we'll start there next time, and we'll cover a bunch of different servers you can plug in to, and the plugin generally works pretty easily between all different LLMs platforms. So you can plug it into Claude, OpenAI, or LM Studio, and it works generally just fine. I've got something wrong in the syntax there. I noticed that for some reason Hugging Face doesn't give you quite the right syntax. I see why. I was on the VS Code syntax. I apologize. Since I see it right now, I was copying the syntax for VS Code. Let me just fix this right now. I can do it. I swear. I won't hold you up more than a second.
Go Tom, go Tom. We are with you.
All right. There's the correct, and notice we have to put in our Hugging Face token, which I'll do real quick. And then I'll cancel that token, obviously. That's just good practice. So a lot of the times you do have to put in your tokens. So that's really easy. Put in the token, make sure you take out the junk. And then we can save it. Now it restarts, and now you can see we have tools. And now if we go back to the chat and we say, which 8B model in the Qwen line do I have access to? It will use this tool to search Hugging Face. And you can see it's calling model search, which is one of the tools we have over here. So I'll leave it there. You can follow this idea, and here it's returning this directly from Hugging Face. It's not making this up from its own knowledge. It's returning an actual search from this Hugging Face MCP server tool. So that's how you extend an LLM with an agent, and there are literally thousands of them out there. So your assignment for next time is to go look for some agents and see if you can get them installed. All right, that's it for today. Thanks a lot, guys. Thanks for hanging in there. As usual, I'll hang in there for a couple minutes. If you have any questions, let me know.
Thanks, Tom. Great class
Thank
as
you.
always.